So we've got a double displacement problem here. What we're trying to do is figure out the single ions that would be used to make compounds A and B. After I've done that, I'm actually going to take this a little bit further and show you how we get compounds A and B too. Alright, so we've got FeI3 plus SrOH2. Now what we know is going to happen is that the Fe will join with the OH, the Sr will join with the I. Alright, so let's see how we work out the ions first. So the best thing to do is to sort of draw this out and figure out what ions we actually have. We've got an Fe and we've got 3 I's here. That's not just a polyatomic ion, that's 3 of a certain single element, which is iodine. So then I can figure out the charges. We know that I has a -1 charge because it's in group 7. That's going to be -3. That means we need +3 on the positive side to match, making the Fe +3. So we've got the charges on those now. Let's look at the SrOH2. That would be Sr and 2 OHs. Polyatomic ion, it's in parentheses. We got 2 of them, so I'll draw 2 of them. We know that that has a -1 charge, and that's because of the polyatomic ion chart. That'll be -2, that'll be +2, and that'll be +2 as well. Note it doesn't matter if you do +3 or 2 plus or 3 plus. Okay, next thing we want to do is we've got the answers now to our ions. So we've got Fe3 plus, we've got I minus, we've got Sr2 plus, and we've got OH minus. And that'll be the answers to all 4 of these. I'm not sure if the order's completely correct, but that's what we're going to have. Alright, so that's how we get the answers to those. The other thing I want to do is go through and show you how we actually get compounds A and B. And what we're going to see is that the Fe3 plus will join with the OH. Now I'm only taking one of these OHs here, so just one of each ion, so I can figure out compounds A and B. And we also know the Sr2 plus will join with the I minus. Alright, so now I can go a little bit further here and go ahead and join those together. So the Fe3 plus and the OH minus, the question I'm asking myself is, how many of these do I need to balance out the 3 plus? I'm going to need 3 OHs to manage that, so it'll be FeOH3. And over here I've got Sr2 plus and I minus, so I hope you can see we need 2 I minuses to balance out the 2 plus on the Sr. So that's going to now be SRI2. Alright, so now we can also look at the solubility chart. We'll see that I don't think strontium's on there, but you can assume it's aqueous since we know that we're only going to get one solid out of here. So we know that that's solid and that'll be aqueous as well. Even though we know Sr is not on that chart, but if this one's solid, we'll assume that one's aqueous. The other thing we want to do is balance up this reaction. And the way we'll do that is to say, well, we've got 1 Fe, 1 Fe, 1 Sr, 1 Sr, but now we've got 3 I's over here and only 2 I's over here. How do we balance those? Well, the best thing I like to do is when it's not obvious as to what's going to happen here, you can't just put a number straight in front of one of them, I like to look at these and say, well, 2 times 3 is 6, so I'm going to need 6 iodines on each side. That means I'll put a 2 in front of here and a 3 in front of here. So that will fix up my iodines. But now I need to fix up the others. The ions now have 2, so I'll put a 2 in front of that, and the Sr needs a 3. Let's see if that works out for the OHs. I've got 6 OHs and I've got 6 OHs, so everything works out. So that's how we would get the entire reaction as well as compounds A and B.